Okay, what's going on, guys? Let's do this problem right here. So we have a guitar string that is fixed at both ends, and if you tighten it to increase its tension, what happens? So the first is saying the wavelength increases but the frequency is not affected. Not true, because we know that there's an equation that is related to tension. Like if you increase the if you tightening means increasing the tension, right? And it's also said here right here, so we can take the relations between frequency and the tension, that is F is equal to square root of T over mu over 2L. And if you see, the tension is directly proportional to F right here, so directly proportional to T, F is directly proportional to T, so if T increases, F increases. So here they are saying frequency is not affected, not true, and wavelength also is not going to be affected because the length is not changing, only the tension is changing. So there's no change in wavelength. The second one is saying both the frequency and the wavelength is increases. Frequency increases, we know, because as the tension increases, frequency increases, but wavelength is not increasing. The third one is saying the frequencies of its vibration mode will increase, but its wavelength will not be affected. So that's the right answer, right? So the answer for this question is C. Let's do the second question. We have that's asking consider the waves on a vibrating guitar string and the sound waves the guitar produces in the surrounding air. The string waves and the sound waves must have same, but so this happens only when they have equal frequency. So we know that this is going to be D answer. And the third question is asking the figure shows the displacement y of a traveling wave at a given position as a function of time, and the displacement of the same wave at a given time as a function of position. How fast is the wave is traveling? So to find the wave speed, we use this formula v is equal to f lambda. Here we had to find out the frequency and the lambda. So lambda can be easily found by position graph. Here this one 3 to 6, if you notice, this is one wavelength, right? And the length of this one wave is called lambda. That is lambda is equal to here 3 to 6, that's 3 meter. And then we have found the lambda right here. Let's find out the frequency. To find the frequency, we can take the time and y graph. So first of all we have to look at the time it takes to travel one wave. So here if you notice, this wave from here to here, it takes 4 seconds to travel. So it means the period of this wave is 4 seconds. So we know that frequency is equal to 1 over t. Here we have 4 second period, so 1 over 4, that gives us 0.25 Hertz. Now we have the f and the lambda. All we have to do is simply multiply both of them, and that's going to give us the velocity. So this is going to be 3 times 0.25, and that gives us 0.75 meter per second, and that is the answer. And here it's given in the E, so E is going to be our answer. And that's how it's done. I hope you guys like this video. See you next time.